Hello, good morning everyone. Now today's our topic is convolution theorem. If L inverse of f bar s is equal to f of t, L inverse of g bar s is equal to g of t, then ft star gt, star means convolution. L inverse of f bar s into g bar s is equal to 0 to t f of u into g of t minus u du. So we have a two type of example in convolution theorem. Sometime you will be given function in terms of t or sometime in terms of s. So if given statement is inverse Laplace of f bar s into g bar s, then we will use this result, this two result. And if given function in terms of t, then we will use this result. Okay. So now how to use convolution theorem? This is the formula. This is the theorem of convolution. Okay. So now this term is in terms of s, right? So we will use these two results. Okay. So for moment, put it side this result. Okay. Now we have a product of two functions of s, f bar s and g bar s. So let's consider f bar s is equal to 1 upon s minus 2 and g bar s is equal to 1 upon s plus 3. What is f of t? If f bar s is this, then inverse Laplace of f bar s is f of t. So f of t is e raised to 2t. And g of t is equal to inverse Laplace of g bar s, means inverse Laplace of this function, e raised to minus 3t. Now we will use convolution theorem. Use convolution theorem. L inverse of f bar s into g bar s is equal to 0 to t f of u g of t minus u du as per the given formula. Now we will substitute the value of f bar s, g bar s, fu and g of t minus u both side. So what is f bar s? We have considered f bar s is 1 upon s minus 2, g bar s is 1 upon s plus 3. Right hand side 0 to t f of u. Now f of t is e raised to 2t. Then what is f of u? E raised to 2u. G of t is e raised to minus 3t. Then g of t minus u. Just replace t by t minus u. E raised to minus 3 t minus u du. Now find out the integration on right hand side 0 to t. You can write e raised to 2u into e raised to minus 3t plus 3u as per the property of exponential function. You can write e raised to minus 3t and e raised to 2u plus 3u 5u du. Okay. Now we are taking integration with respect to u, but this term you can consider as a constant because it is e raised to minus 3t. So e raised to minus 3t you can take constant, and integration of e raised to 5u, e raised to 5u divided by 5, 0 to t, e raised to minus 3t by 5, and replace u by t and u by 0. Now we are putting upper limit, so e raised to 5t minus e raised to 0, 1. You can simplify further by multiplying e raised to minus 3t. So 1 by 5 constant, e raised to 2t minus e raised to minus 3t. Okay, this is the final answer. So if we have a product of two functions of s, and you can find out the inverse Laplace of both functions, then this theorem is best suitable. Okay. Similarly, we have a second question. Again, we will use convolution theorem. Think about it. Now we have two functions we have to separate in two functions. So let's consider f bar s is equal to s by s square plus 4 and g bar s is equal to 1 by s minus 1. As per the convolution theorem, by convolution theorem, now I am not writing statement again, I will put values directly. So L inverse of f bar s 1 upon s minus 1 into g bar s. So the product of these two functions is the statement of 0 to t fu. What is f of u? So we have to find out the inverse Laplace of f bar s. What is inverse Laplace of f bar s? F of t is cos 2t and g bar s, g of t e raised to t. So as per the theorem, 0 to t f of u means cos ft is cos 2t. So f of u is cos 2u and g of t is e raised to t, but right hand side part of the convolution theorem is g of t minus u. So we will write this way. Now again you can take e raised to t constant and remaining term e raised to minus u cos 2u du. Okay. Now think about this integration. How to integrate this term? So we have one formula, e raised to ax cos bx. Okay. So e raised to ax by a square plus b square. A cos bx plus b sin bx. Okay, this is the integration with limit 0 to t. So which formula we are using? Not limit is required, but e raised to ax cos bx dx. E raised to ax by a square plus b square, a cos bx plus b sin bx. Okay, this is the integration. So this integration we are using. Now substitute upper limit and lower limit. E raised to t, you can take 5 constant. Think about remaining terms. Replace u by t first. So it is e raised to minus t. Here when you will replace u by t, so this term will be minus cos 2t plus 2 sin 2t. Now think about lower limit. Replace u by 0. This term will be 1 minus cos 0 is 1. Sin 0 is 0. So minus sign is there, but we are putting lower limit. So you can write minus minus plus 1. Okay, plus 1. Done. Clear? Because cos 0 is 1 and sin 0 is 0. Simplify further. You can multiply e raised to t. 1 by 5 constant. Final answer will be minus cos 2t, 2 sin 2t plus e raised to t, because we are multiplying by e raised to t. Okay, this is the answer. Now here you have to think about f bar s and g bar s. So you have two options, either you can take s upon s12 plus as f bar s or g bar s. But when you will take this function as g bar s, so it will become easy, because it is easy to take constant e raised to t. When you will take this function as g bar s, so it will more difficult. It is not impossible, but it is difficult. So if any function, inverse Laplace of any function is exponential term, so prefer to take as a g bar s. Okay. Now, as we discussed in convolution theorem, we have two types of the statement, in terms of t and in terms of s. Now this case we have discussed. Now we will discuss about this case, ft into gt. So sometime you will get this type of example, t star e raised to t, where star means convolution. So find out t star e raised to tt, e raised to 2t. So what is the convolution theorem? Convolution theorem is ft star gt is equal to 0 to t f of u g of t minus u du. Okay, f of u. So now t star e raised to t. So we have to consider any one function as ft and another function is gt. So let's assume ft is t and gt is e raised to 2t. Now substitute this value in this convolution theorem. This is convolution theorem. T star e raised to 2t, 0 to t, where fu is, ft is t, so you can write u, g of t minus u, gt raised to 2t, so g of t minus u, just replace t by t minus u, so it is e raised to 2 t minus u du. Now think about integration, where e raised to 2t is constant because we are taking integration with respect to u, 0 to t u e raised to minus 2u du. How to integrate this? By integration by parts, or you can use Bernoulli formula. It is easy as compared to integration by parts because it is general form of integration by part. So consider this function as u and this is v, okay, because this is a polynomial. So u integration of e raised to minus 2u by minus 2 minus derivative of u 1 and then integration of this function e raised to 2u by 4 and limit 0 to t. So in order to evaluate this integration, you have to understand Bernoulli formula of integration. Okay, we have used this result. Okay. Now replace u by t. T e raised to minus 2t divided by minus 2, e raised to minus 2t divided by 4, replace u by 0. So this term will be 0 and this term, but lower value, lower limit. So due to lower limit and already we have a negative sign, minus minus plus, and e raised to 0 is 1 by 4. Now you can multiply e raised to 2t. So e raised to 2t into e raised to minus 2t is 1. So 1 by 4 and last term is 1 by 4 e raised to 2t. So this is the second case of convolution theorem. So in convolution theorem is very important theorem of Laplace transform. So there are two types of example. Sometimes you will be given function in terms of t or in terms of s. So in terms of t, so no need to find out the inverse Laplace. Directly you can apply this result. Okay. Thank you.